We're in section 3.1. So hyperbolas. Alright. I've heard it said a lot of ways. I'm probably saying it wrong, not gonna lie. So here, definition of hyperbola. So here it's so in the ellipse we have the set of all points and planes which were the sum was the same. Here's the difference. And two fixed points are called the foci. And so what they look like is kind of like two parabolas, right? So we'll have one parabola and two parabolas, and then we'll have it make it a little bit more the same. There we go. And then we'll have some foci here and some foci here. And so here, if we went from this point to this point, and then this point to this point, if I minus these two distances, it would be the same if I went from this point to this point, from this point to this point. So here, the difference of these should always be the same, no matter what. Okay, and so that's the geometric definition. Let's get into the kind of the equation definition. So here, notice what's different here. This is still a 1, so this is still a 1. In this case, we'll have it minus, right? A will still be, so in this case, it doesn't matter. A may be greater, B may be greater, so A is just going to be what's on the underneath A is going to be the one that's positive, right? And here is and then the one we negate will be B. Okay. So our vertices, since we're still centered at the origin, will be plus or minus A, or 0 for the horizontal one. So if we're on the X, we plus minus A. If we're on the Y, we plus or minus, or 0 plus or minus A for the Y. So let's go ahead and sketch these as we do this, so it makes a little bit more sense. So here, for the horizontal one, we'll have here and here at, and these will be at, so this is at A0, and then so the transverse axis, so how long this axis is 2A, and then here could be here and here. So this is at A, this is at A, this is at A, this is at A, and so what we have here is we have from A to A, from A to A, and then here we have our asymptotes. And so asymptotes are lines in which nothing can pass, and this will be at, and so we'll have these two things. And so the best way to do this is kind of draw a box. And so we'll have B here based off of this. We'll have a B here and a B here based off of this. And so here we'll just draw this box right here. And then draw this box. That's a B. And make this a little bit more equal distance. Oops. Go back. Make this a little bit easier to see. So this is A, and then here we'll say B and B for this case, and we kind of draw a box here. And then we'll put, say, B here and B here, and we'll draw a box here. And then that way you can just kind of put our dotted lines right here. And notice this line, oops, I missed my dotted line. Just put it like here. And notice that this line right here will be X plus B over A, or A over B, right? For this one. And then this one would be B over A. Here we have rise over run, and here we'll have rise of A and run of B. Here we'll have rise of B and run of A. And so here we get the same one. And so here, once we've drawn this in, we can just, I'll go ahead and draw the parabolas in this. I'll just do it in green. Or the hyperbolas. And so you have two parabolas. One comes in kind of like this, one comes out, and they'll just not pass these asymptotic lines, but they'll touch the vertices. And the other one, here we have it vertically, it'll come in, and come out, and then come in, and go out. Here, when we're doing the foci will be past A, and so it's A plus our B, and so C squared equals A plus B, so here will be our foci, in this case, of C out here, and then here we'll have our foci of C out here, okay? And so this is just how we put it together. This is how you draw it. In fact, I'll give you steps on how to draw it. So the first thing is sketch the central box like I did. You know, mark your A's, mark your B's, draw the box. Rectangle around the origin, and then sketch your asymptotes. So go ahead and do dotted lines across this. Plot your vertices. So your vertices, so here it's for the horizontal one would be here and here, or the vertical one would be here and here. So vertically or horizontally. So these vertices right here. So we're going to plot those, and then just sketch the hyperbola as so. Start at the vertex and kind of branch out and fade again, or I like to come in, barely touch the vertex and head back out. Okay. So let's do some practice problems. There's some problems. And so here we want to find the vertice, evoke asymptotes, and sketch the graphs. And so let's start with this one. So here, first thing we need to do is divide by 144. So when we divide by 144 to both sides, what we'll get is the following. We'll get x squared equals 16 minus y squared equals 9 equal to 1. Okay, so now we have a 1 here. So notice we don't have a 1 here. We have to do math until we get there. Alright, so now that we know this, we're going to find C. C is equal to the square root of 16 plus 9, which is the square root of 25, so it's equal to 5. So we have everything we need to do. So our vertices here will be, since it's over the x is our positive one, we'll have plus or minus 5, 0. Our foci, oops, no, the vertices would be plus or minus 4, sorry. Go back. It'll be here, so it'll be 4 and 0. Since this is 16 is the same as 4 squared, I guess I should write that. X squared is equal to 4 squared plus, or minus, in this case, y squared over 3 squared equal to 1. So we have our vertice, we have our foci. And we have our asymptotes. Asymptote. There we go. Our foci will be at plus or minus 5, and our asymptote will be at plus or minus 3 over 4, in this case, x. Alright, so let's go ahead and sketch this. Now we found all those things, and so let's sketch our graph. So here we're going to go out to 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. We're going to draw our box in. So we're going to draw this nice central box. And then we're going to have a dotted line through the corners, which equal our asymptotes. And then I'll go ahead and do this in green. Oh, I forgot. Here we have our focus at 5. Here's our focus at 5. And then we'll do this in green, and we'll just go ahead and sketch it right on in. Okay, so that's we do this one. Let's do the next one. So the next one, what do we have here? We have this. So we want to make this look the same. Oops, sorry. This should be a negative. Go ahead and fix that. I'll fix it on the notes before I upload it. So here we have this. So we need to make this look like 9 squared minus 9y equals minus 9. So we move the minus 9 over. We divide by the minus 9. We'll get y squared over 1 squared minus x squared over 9, which is the same as 3 squared, equal to 1. Okay, so now we have this. we can write out our stuff. So our vertices, even though this is the larger one, our vertices still occur with the y because that's the positive one. So it'll be plus or minus 1, or no, it'll be 0 plus or minus 1. Our foci, which we have not found yet, so let's go ahead and find that. So our foci would be c is equal to the square root of 1 plus 9, so 3 squared, 9, square root of 10. So our foci occurs at 0 plus or minus square root 10, which is just a little bit bigger than 3. And our asymptotes. So our asymptotes here are our asymptote will be y is equal to, oops, I forgot my y is equal to here, plus or minus, and then here, we look back here, what is it? It is a over b, or a is over this one, so it'll be 1 over 3x. Alright, so we're going to draw in that box, so we'll have 1, and then 3, and then 1 and 3. And so here we have 1, 3, 1, 3, and so we now go ahead and draw our asymptotes in. So we just right through the corners, right through the corners. And then here we'll have our, just be a little bit past 3, a little bit past 3. And we'll go ahead and draw this in. So this one's pretty wide. Comes in, comes back out. Comes in, touches the vertex, and then comes back out. Alright, so let's work backwards for a second. So, find the equation of a hyperbola with vertices of 3 and a foci of 4 and sketch the graph. Okay, so here, let's do this. So, what do we know here? So we know that if the vertices are at so here if we have the vertices at 3 and the foci at 4, I know this is horizontal, right? So this is a horizontal thing. So let's figure this out. So this is horizontal, so let's go ahead and plug in what we know. So we know this is 3. No, I'm still in green. So let's go ahead and this is 3. This is 3. And then our foci would be at 4 and 4. And so I know that 4 is equal to 3 squared plus b squared. And so that means b so 4 squared minus 3 squared is equal to b. And so b equals the square root of 16 minus 9, so the square root of 7. And so our equation here would be x squared over, what's our equation? Our x squared over 3 squared, so 9, plus, or minus, y in this case, square root of 7 squared, so it's just 7 equals to 1. And so here's our equation. So here's our c is equal to square root of a squared plus b squared. We know that this is a, so we have 3 is a, and then here we can find out what b is, since we know this is c. And so here we found the equation. We'll sketch the graph. So it'll be the square root of 7. Square root of 7 is a little less than 3, so 1, 2, a little less than 3, so it'll be here and here. And just draw the box. Draw in our box. Go ahead and put in our little asymptotic lines. We don't have to solve for it this time. We'll just draw them in, and then we'll just grab this and just say, here it comes, and it comes in, touches the vertex of 3, and comes back out. Here it is. vertex of 3 and comes back out. Alright, so let's do this again. Let's find out the equation. So here we'll have find the equation foci over vertices are 0 and 2. So now we know we're here and here. So we have a vertical one. Oops, here and here, sorry. So we have a vertical one. And our asymptotes are 2 over 1, right? So here, if our asymptotes are 2 over 1, and I know this is 2, so that means that this means that A is equal to 2. Here, if it's 2 over 1, that means, oops, that is not a 2. That means B equals to 1. So we can quickly write down this. So we have y over 4 minus x squared over 1 equals to 1. And the reason we know, here we have plus or minus 2, but if we just look right here, we can figure out that B must be 1. Okay. So here we go. So we found the equation. We can sketch the graph. So we have 2, 1, 2, 1, 2. Go ahead and put in our asymptotes. We can sketch the graph. Okay. And then the last thing we want to do is find our foci. So our foci is going to be c squared is equal to, or c is equal to the square root of 4 squared plus 1 squared. So we'll have, oops, not 4 squared, but 4, since it's really 2 squared, and 1. So this is just the square root of 5. And so here, our foci in this case will be 0, since the foci are in this direction now, plus or minus square root of 5. And that's it. And that's the end of these notes.